Folks. All right, so real quick before we get started, um, midterm grade is looking good, not bad. Um, mostly B or higher, which is awesome. So, questions about that. All right, so the grade book. I've got a lot of questions about the grade book specifically for lab. It's max, and it's not entirely my fault. It's the way it was loaded. And then like there's regions for like stuff that we didn't even do, and there's like areas, there's like not areas for things that we did do, which I thought we were doing. So it is a disaster, and I know that's like really frustrating for all of you, and for the people who are going to be watching this recording. So on the other lab class, I put an announcement out, which I don't know if you guys interact with people who are taking that class. I don't know if you've seen it or not or whatever. Basically, the way this class is going to be graded is it's going to be because of the disaster that was in the beginning of the semester and not really knowing where to go, and then taking it in a couple different directions before kind of finally settling in and figuring out what I should make do and when. I'm gonna give you a blanket statement, okay? Any histology Dropbox, top hat, quiz, anything that's not a midterm or test, it's going to be largely participation credit. Okay. Um, I don't know how that's going to work. I'd love to just be like, yeah, 60% of it's going to be like all of that stuff. So if you're doing stuff in this class, great. Don't worry about it. You're probably going to get full participation credit. I need to figure out a way that I can do it so that it's not just like subjective. You should know I can see when you access this class. So if it's been 3 weeks since you've logged on and done anything and you didn't turn in your top hat, and you're emailing me like, oh, I need to get my grades up, I don't know what to do. Like you're for sure not getting full participation credit. I'm just not sure how that's gonna work. I'm envisioning that there's probably going to be some sort of threshold that if you did 4 assignments or something, you'll get full participation credit. Okay, that means that's a big chunk of your grade that will be like 100%. Okay, um, so there's that. I just haven't quite figured out that part of it yet. Okay, I need to talk to some people and figure out how they're doing it and also what to do from here. Okay, I kind of need a little bit of guidance. The midterm and the final are going to be a good chunk of your grade as well. Okay, they're basically to give you the background. On like one of the syllabuses that I was given, it gave a midterm and a final, and then whenever I was like put in the class and it loaded into Blackboard, the midterm was broken up into like 2 or 3 tests and then a final, which nobody ever found anything about. So that's why we ended up with a midterm because by the time I realized that, we'd already moved past the first test, and I didn't want to give you a test from like 3 weeks ago. So yeah, so midterm final, and then like other things, which out of fairness, I'm probably going to make a percentage of that participation credit, a large percentage of that. And then there might be some like graded stuff on the last half. So what that means for y'all is if you haven't done anything in this class, you're doing badly. And I don't mean that to like scare you, but like there have been instances where I've said, do this histology Dropbox, and nobody did it. Not nobody, but like half the people did it. or I've been like, here's top hat, there's a due date assigned to it, and people just straight up didn't do it. So, if that includes you, get in gear. Go do some of that because the due dates are not like public, and you can still submit to them. Okay. So if you look at your grade book and you have done absolutely nothing that's in there, go turn it all in because I'm gonna have to grade off of something. And if you don't give me anything, then I can't give you anything. Okay. Um, try a little bit. Like, don't just upload a whole bunch of blank PDFs if you're gonna go through and do a whole bunch of histology drop boxes. Um, like put like a tiny amount of effort into it, and you'll probably get full credit. Um, I don't know how the top hat translates to the grade book. Um, so I don't know if it's gonna give like if it's gonna allow me to like adjust the credit, but I think you have unlimited attempts too for it. If not, I'll check into that and make sure that for the rest of the semester you do. Um, and then going forward, I'm probably on Saturday going to sit down and really deep dive what the rest of the semester is going to look like. So I'll be able to give you like clear, here's dates, here's, do this throughout the whole thing. Okay. And then the final will be on whenever they do the finals week or whatever. And that's just going to be last half stuff. So I think for the lecture, I don't write the final. So I think for the lecture, it's going to be cumulative. And then, but don't hold me to that. I'm not 100% certain. I just kind of remember somebody saying something about that. But for this class, out of fairness, I'm going to like make sure that it's not. So don't worry about that. Yeah. Does anybody feel like that's like not fair? And I get the most fair thing would be to have like a normal class, and we just don't have that. So, any objections? Um, any suggestions? Maybe would be great. So yeah. Also, you guys are lucky if you're taking live class because the asynchronous class, the Blackboard was really jacked up. So there was like nothing I could do about that. And they didn't even get to start their midterm until today, which was so annoying. So I get it. It sucks. And it's annoying to have to take a class like that, especially a lot of you are relying on good grades for other reasons. Um, but that's all I can do for you. So, thoughts? This is an open forum for a few minutes. Yeah, that's what I'm saying. Like largely participation. If you opened it, yeah, no. If you opened it and looked at it and did a couple questions and had no idea what was going on, I'll probably give you full credit. If you straight up didn't touch it, you'll probably get no credit for that. Like that's kind of what I'm saying. Like I can tell if you are participating. It's not a big secret. Blackboard tells me when you log in and how long you spent. So, like, I can go back and say, okay, this person spent 12 minutes logged into this class and did no assignments. You're not getting full credit for participation. I can also look at other people and go, this person logged in every single week. I know there was nothing due this week, but they just were checking and they actually did all their assignments. Full credit for participation. So yeah, the ones that were assigned for review, though, I was doing that for you guys to be able to review it. So I don't know about that. I don't know. I'll have to noodle on that. I think that's what you're talking about. The ones that were for review, don't worry too much about those. But if I gave you, like, there was one period where I was like, here is a list of a couple top hats, go do them, here's the due dates. So if you just ignored that, no points for you. Does that kind of answer your question? great. I want to pass you guys, and I want you to get A's. So just know that that's where I'm coming from. But I'm not sure what I'm allowed to do. So, like straight up, I would, if it was up to me, I'd be like, everybody for the first 5 weeks gets 100% credit, and I don't care. But I'm sure they'll have a problem with that. So, doing what I can to be nice, and also kind of, will there be an option for extra credit? Sure, it's right now. Go do anything you haven't done. I'm going to give you a large part of your grade is going to be participation extra credit. So past that, probably not anything more than like one question. Also, I just tried to put an announcement that was like, somebody told me what's wrong with my eye, and I'll give you a point of extra credit, and nobody answered it. So, except one person. So I gave her an extra point. But it's too late for that. It's gone. Any other questions, comments, concerns? All right. Well, if you guys think of anything, or if you're like, what about this? I'm open to suggestions that you think might be more fair. I feel like that's fair. I know that doesn't really give you a whole lot of clarity, um, but hopefully, like on Saturday, I should be able to give you a lot more clarity. Um, yeah, my family's leaving for the weekend, so I get to do a lot of actual work on Saturday. So hopefully, I have everything for you guys. Like I'm empty house, caffeinated, gonna finish this out, and probably plan for next semester. So since I didn't get any planning time this time, so but yeah, if you have suggestions or are like that's not fair, then email me, and I'll probably delete it. I'm just kidding. I read it. I read all the emails. All right. For today, we're gonna go over a suggestion that somebody had, which is we should review the top hat stuff. Oh, three for a single Dropbox. Do we do all three or do one? I don't know. You read the directions at least, just more than some people did. So just do one. Just do one. Like literally, just do. All I'm asking for is you to do anything. Like I can't. I can't grade you if you do nothing. So like, just do something. Like please, I'm begging you, just to help me out and do any of the assignments that you have access to, and at least I can be like, this person's participating, full credit, yay for them. So I feel like I'm running a course on what's that called? What's the class? The movie. Accepted. I feel like I'm teaching at South Harmon Institute of Technology where everything's made up and we just go off of that. Yeah, that's pretty much what's happening here. So um yeah, and also like I get it. Like it's super annoying for you. Like you guys pay for this. So, I get it. I'd be annoyed too. I'm doing my best to help. I just don't know what to do. All right, let's move into some of the lab stuff. Send me your email thoughts. Okay. Sure. Okay. So here's what it's gonna look like. We're gonna go over some top hat thingies, and then I'm gonna run through some of the histology stuff for lungs, and then we'll have open questions. Okay. And ready to go. Wait. Ready go. Okay. So lungs. This is your pre-lab stuff. This is in present mode. I don't know if it. I think there was like some of them I can like ask questions and quiz you guys, but I haven't figured that out yet. Again, I have no idea what the heck I'm doing. Um, so respiratory system. This is the basic anatomy. We kind of talked about that a little bit already. So air goes in, it goes around here, and then it comes back out. Okay. So this is what it looks like in plastic. This is an artist rendition. Go figure. All right. So we have lungs. All right. So on the interior side of the lungs, so let's call it the mediastinum, or what would this technically be? This is the hilum, but this surface is the medial border, medial margin, maybe. But anyway, the only important thing here is this. So this is the hilum of the lungs. So if we look at this picture right here, you can see it's connected right there, and then there's also little like uh, vascular connections right there too. Okay, so this thing is called the hilum. So we have the primary bronchus that goes straight into there, and then we have the pulmonary artery, the pulmonary vein, and then having lymph nodes too. So what would be the benefit of having lymph nodes right here? Anybody want to guess? Anybody? So this is where I think I can answer. Yeah, right by the blood. And really more importantly, it's right by the airway, right? So like this air that's going through here and bringing in bacteria, it can just respond like straight into that spot. Okay. So there are lymph nodes, there's a lot of lymphatic stuff, there's pulmonary veins, and then these individual like sub-segments are called lobules. Okay. Um, there's a fissure, so there's a horizontal fissure right here, and there's an oblique fissure right here. If we have a horizontal and an oblique fissure, which lung are we looking at? It's the right lung. It's also labeled. So, and this was probably a dead giveaway. All right. So yeah, that's the lungs. This is the respiratory system. You should learn that. We already went over it. Here is a breakdown of all the bones. Not really the one bone and the larynx, right? And that's the voice box. Okay. Bronchuses, you have primary, secondary, tertiary, and then terminal bronchuses. Okay. And it looks like that again. And then we've got the bronchiole and the alveoli. Okay. So let's kind of move past that a little bit and go into, actually, would it be helpful to go through this, like answer the questions? You tell me. I don't know if you've already seen the correct answers because it was already due. So like I can show you, but does that like what does that do for you? Is that helpful? I turned it green. Yes. Okay. Well, there you go. There's the answers. Um, so the respiratory tract is a series of highly branching passages that conducts air to the structure for gas exchange. Those structures are called alveoli. Okay. The pleural cavity is the potential space between the parietal and visceral pleura filled with serous fluid. Potential space, is that a new term to anybody? Do you guys know what that term is? Or is this the first time you've ever heard the words potential space? First time for you? Okay. All right. So in anatomy, we have these spaces between two structures that connect, right? So like, um, so that is, it's the defining, let's see if I can find like a, it's an area where there's spaces that have potential, obviously. It's areas like the pleural space, right, between the visceral and parietal pleura, where you could pull them apart. You shouldn't, but you could, or they could be filled with fluid, right? And the what creates potential spaces generally is germ layers. So if you watch the embryology lecture, you know that most of your organs arise from individual germ layers, right? So they're growing in, they're pouching out, and then they're folding over, right? So this is where like little foldovers will happen. So this is the peritoneal cavity. So like this is a space, this is a space, this is a space, right? So those are potential spaces. They could be potential fluid spaces, or they could be like compartments, kind of, where it might be the same cells just kind of folded over on each other. And what that creates is like for the lungs, for example, like this is all the same cells, right? And then this is similar cells, but they're stuck together. Or it could be for like the peritoneum. Okay. So like there's space around your kidneys, right? Like everything kind of fits in pretty well and your body will like fill in that space. And it's not like you have like a kidney hanging out and then air around it. It's just like if you were to, I don't know, get a surgery and they would shove like a little air tube in there and blow up like your abdomen, which is why you have to fart after surgeries, laparoscopic surgeries especially. Um, these are spaces that would like fill up with that air if you could. So you shouldn't, like they shouldn't normally, but they could, right? Like you could end up with a space like an air pocket here or something. Um, so yeah, like this is all potential space between different organs. Okay. Um, It's not like a wildly important term. You should just kind of know what it means, right? Because they could be very thin, and in the case of the pleural cavity, or they could be like super big, like the uh, like in the abdomen. There's like the retrourinal space. That's pretty big. You can shove a hand down there, or between your, let's see, where is it? um, your posterior pharynx. There's a potential space between your posterior pharynx and your posterior neck muscles, and you can shove your whole hand down, like if you wanted to. So it's a big potential space. And it's why infection can move up and down real quickly. So, and yes, you can shove your whole arm down there. It's wild. It's a weird feeling. Weird to get out of that. It's like, it's big. Okay, so lungs and lobes. Lungs are elastic connective tissue and tiny air sacs. So these alveoli have a whole bunch of connective tissue around them, which we're going to get to in a second. And then it's divided into sections, 3 on the right and 2 on the left, called lobes. Okay. All right. I won't do like all these, but you should know like respiratory bronchioles are branches off the terminal bronchioles that have alveoli within the walls. The alveolar ducts themselves are the area of the respiratory bronchiole made up exclusively of alveoli. So we're going to get there. There's a histological difference between that and like the rest of the lung tissue, and we'll see that. Okay. And the alveoli are the terminal lung structures. Okay. So let's talk respiratory tract real quick. Okay. Um, the histology of the respiratory tract. So if you were to take, if this is an alveoli, for instance, right here, this big round area, you'd have a space right here, a potential space, not really, but it would be airspace right here. And then you have a mucosa, right? You have a submucosa, you have cartilage, and this is trachea, by the way. And then you have adventitia right here. Adventitia is connective tissue. They're synonyms, okay? And the reason it looks like that is, again, we talked about it in a little bit in the embryology lecture, is your lungs are arise from endodermal tissue, which comes from your digestive system. So if your digestive system is lined with epithelial cells, so is your lungs, right? So you'll see that kind of same trend of like a mucosa, a submucosa, and then an adventitia or like a basement membrane. Okay. So let's talk mucosa. In the lungs, the mucosa is a pseudostratified ciliated columnar epithelium with goblet cells. Let's break that one down a little bit. So let's see. Okay. There are 8 different types of epithelial tissue, and let's talk about what they all look like. This is a good picture. Okay, so you have simple squamous epithelium, which is a single layer of flat cells. Okay, that's your like normal looking epithelium. Okay, just flat, laid out. Okay, then you have simple cuboidal. So these are just literally cubes. Okay, they're cubes of epithelium, and that's the way they're shaped. Okay. We could get into why they're shaped that way, but I don't think you should care about that because it's biochemistry. Then you have simple columnar epithelium, same thing. So generally speaking, simple columnar epithelium is ciliated. Okay, it's got these little things right here at the top called cilia. Okay, so those exist in the uterine tube, uterus, and intestine. And then you have pseudostratified columnar epithelium. So this is kind of stratified, but not really. So when you look at stratified, stratification is like there's different layers, okay? So it looks like there's different layers because these nuclei are at different levels. So it looks stratified, but if you zoom in, it's not. It's columnar epithelium that looks like stratified. Okay. And then you have other actual stratified stuff. Okay. And this pseudostratified columnar epithelium exists only in the respiratory tract. Okay. So if you're looking at a slide, like a histology slide, and it has pseudostratified columnar epithelium, you are looking at the respiratory tract. Okay. So zoom in, figure out if it's pseudostratified or regular stratified, and go from there. Okay. The big giveaway is the nuclei at different levels. Okay. Some of these are goblet cells and some are not. Okay. Which is why we have nuclei in different levels. These are all the same cells. Okay. These all do the same thing. These don't all do the same thing. Okay. Then we have stratified squamous epithelium. So this is like skin, right? So like different layers of skin. And then we have stratified cuboidal epithelium. That's mostly in glands. So if you're looking at stratified cuboidal, you're probably looking at a gland of some type, like a sweat gland, and if they're usually secretory, okay, they're secreting something, okay. Then there's stratified columnar, which are multiple layers of tall cells, and those exist in the urethra and other glandular ducts, okay. And then there's transitional epithelium. So those are cell, which is not technically like its own type of epithelium. It's different types of epithelium going from cuboidal to flat. Like they're just kind of flattening. And that happens in the bladder, in the ureter, in the urethra. Okay. So this is a good picture to know. And it's pretty easy to Google too. I just Googled epithelium types. It was the first hit. Okay. So you need to know the difference between those if you're going to learn histology. Okay. All right. So we're looking at this. So you can see right here, actually right here, this is pseudostratified ciliated columnar epithelium. So pseudostratified because the nuclei are at different layers. They are ciliated. You can see the cilia right there. And they're columnar. which the big long rectangles, and they're epithelial cells. Okay, these are not myocytes; they're epithelial. Okay, pretty obvious. Then there's a submucosa, right? Which these are going to be more like simple epitheliums. And then there's submucosal glands, which you can see it's a gland. It's kind of surrounded by cuboidal tissue. And then blood vessels. Okay. So you've got pseudostratified ciliated columnar epithelium with goblet cells. These are called goblet cells. This is what squeezes out the mucus. Okay. There's stratified squamous epithelium, so you do have those flat layers of epithelium. What's the benefit of having that in like the oropharynx and the larynx and all of those like upper respiratory things? The answer is like literally there. It's mostly protective. Okay, so you can damage a couple layers of it and it'll just slop off. All right. Same reason why you have stratified squamous epithelium on your skin, right? You can damage this, it'll just slop off, right? So yeah, the simple cuboidal epithelium are line the bronchioles, right? Because is it 22.9? Is this one? No, this one. So where are they? Bronchiolar smooth muscle facility here. And the reason for that is because um, what's the reason for it? It's think of it like a cleaner secretion, I guess would be a good way to put it. You've already kind of gotten rid of all the dust and debris and any damage from like the squamous epitheliums and stuff like that. So you end up being able to kind of use different cells to secrete stuff. Okay. Um, the alveoli are simple squamous epithelium, and they consist of mucosa only. This minimizes the distance gas must diffuse across the alveoli and pulmonary capillaries. Okay, so you're taking big long cuboidal cell or columnar cells, you're squishing them down, and gas exchange can go through this instead of all the way through here. Okay, so very fast gas exchange. That's why you want simple squamous epithelium in the alveoli. Okay. All right, and this is kind of what it looks like a little bit. So if I give you like a slide and say, hey, here's the respiratory system, what are you looking at? And you see only simple squamous cell epithelium, alveoli, baby. If I give you a slide and you see goblet cells, what are you looking at? Probably maybe a tracheum or a bronchial, but definitely not an alveoli. Okay, good test question. What are you not looking at? An alveoli. All right. So submucosa is deep to the mucosa, so deep or superficial. So you have mucosa, deep to that is the submucosa, and that is loose connective tissue. We don't get into the different types of loose connective tissue. Just know that sometimes connective tissue can be loose or dense, or a combination. And you'll be able to tell. Like if you're looking at connective tissue in a microscope, you'll be like, that's loose connective tissue. It's very far apart. There's spaces between it. Within that, there are seromucous glands. So there's mucus that gets kind of pumped up to the goblet cells and out, right? And then deep to that is the adventitia, which is dense irregular connective tissue with elastic fibers. So if we're looking at that picture again, you can kind of see this is loose, this is dense. So these have spaces. This is really dense. The collagen fibers really pick up the stain. That's why it ends up looking like that. Okay? Lung inflation. Let's not go over that. And okay, cool. That wasn't too bad. What's that? Let's not do that. This is more anatomy. We kind of already. Oh, this is like chest questions and stuff. Since this is a sign, I don't want to give you the answer. The answers. But we can do it together. We could do it together as a class. Sure. Let's try. Is it giving me my responses? Oh, 7. Look at that. It does give me the answers. Let's see what people think of this so far. All right. Number 1. This is a bone. What is it called? Yes, it is. I don't know where all that stuff is. It must just not look like that. Okay. Yeah, that's correct. Number 2 is cartilage. Which one? Yep. Number 3 is also a cartilage, right? Yep. So thyroid, and then cricoid right below it. Think back to Grey's Anatomy. I need cricoid pressure. What does that mean? They're looking for the cricoid, and they want to put the tube here, right above the cricoid. So cricoid pressure, they're looking for it. Number 4 is the trachea, obviously. What are the D's mean? Yeah, this is horizontal fissure. This is diaphragm muscle. So pretty easy. Let's skip all the easy stuff. You guys can do the easy stuff on your own. That's pretty easy for you. Oh, here's a good one. What are these called? These little thingies. Yes. Check one. Yes. Because we have an oblique fissure over here. So both of them have oblique fissures. Only one has a horizontal fissure. Why? Because what's right here? The arc. That's correct. Thank you for playing. All right. Okay, the sinuses. That's a good question. The sphenoid sinus. What runs through the sphenoid sinus? Or the sphenoid bone, I should say. It lives right here. This is the sphenoid sinuses. This is the sphenoid bone. And there's little holes right here for something to go through here. What's going through that? No, you're close. You are one. Nope. Yeah, you're one cranial nerve away. They are called olfactory neurons, right? Because your olfactory bulbs are right here. So they're shoving through the sphenoid. Okay. Um, Pharynx, did you guys learn cranial nerves yet? Do I have to teach that to you? I don't think that's me. I think that's, is that AP1? Do you learn cranial nerves? That was one. Okay. All right, so you should have just known. I'm just kidding. All right. Pleural cavity contains a thin layer of blank, which functions to blank. Any guesses? Let's see what you guys guessed so far. Mostly B. Well, one person. Shame. All right. Mark is true and false. If the statement is false, correct it to make it true. Wow, that's a lot of work. I have to grade those. Participation credit. Let's go through this. Trachea is lined with O-shaped rings of hyaline cartilage. Is it hyaline cartilage? What's that like? No, I think this is wrong. I shouldn't do this. No, no, don't do it. Don't do it. Yeah. Okay. I don't like how this is working. So, um, yeah. Various sinuses filter warm and humidify inhaled air. Yeah, sure. Superior vocal folds are the true vocal folds. Vocal cords. Are the true vocal cords superior or inferior? That's a great question. Inferior. Anatomically inferior. They're generally superior. Think you're gonna hate this analogy. Think female reproductive system. Okay, there is folds that are exterior and interior, right? Maybe majora and minora. Kind of the same thing is happening here. You get that folds, those folds over that are more protected than anything. And there's probably better examples throughout the human body. But that they all kind of do the same thing. Okay, so you have your superior vocal folds that are kind of mostly protecting the inferior vocal folds. And the ones that are on top are not true vocal folds. Those are just covers, right? So you pull those back and then you've got your inferior vocal cords. That was a terrible analogy. I mean, it wasn't, but it was weird. But anyway, that's kind of what's going on. So you've got like a protective fold over your vocal cords. Okay. Epiglottis would have been a good analogy. You're covering your respiratory tract. I don't know. What do you want? Left primary bronchus is shorter, straighter, and wider than the right primary bronchus. Yeah, it actually is. I think. Yeah, because the right one you kind of loop up. Fun fact, if you're gonna choke and die on something, it's more likely that it ends up in your left primary bronchus. Go figure. Bronchioles are passages of the respiratory tract that are less than 1 millimeter in diameter. Sure, maybe. Uh, Over that. Trying to find the respiratory tract. Yeah, these are good. see responses. Is not a trend. Yeah, so if this is the correct answer, why would it be the correct answer? Does the epithelium gradually increase or decrease in height as we move deeper into the respiratory tract? Kind of just cover this. Yeah, as we move deeper to get to the alveoli. But you were down the right track. It decreases, right? Because we go from the pseudostratified columnar epithelium to the squamous epithelium, right? Right. That's right. Which of the following about the alveoli is true? That's pretty easy. Which one is not one of the components of the respiratory membrane? Ooh, question. I'm going to give you the answer. Let's see responses. Yeah, you're almost right. All right. Let's do these for your response questions. Here. Okay, cool. All right, cool. Yeah, most of these questions for respiratory tract are how can you choke and die, which is awesome. So, um, yeah, I think generally speaking, like you guys will have the idea of this. This is way easier to trace than like vessels, right? Nobody's gonna say go all the way to your finger on that. So I'll look at these. I'll give you guys some feedback if I get a chance, and then yeah, we'll go through those. So that's post-lab stuff. One thing I did want to look at is on histology guide. This is last thing, real quick. Okay. I would recommend going through this. Okay. Really find some differences between like the different areas of the respiratory tract. Okay, so like take this trachea and look at the epithelium. Okay, pseudostratified columnar, and you can see like some areas are going to be like look weird. You're like, that doesn't look like it. But then some other areas, like look at this. This is columnar fasciae. Okay, this is columnar fasciae. This is a goblet cell. This is a goblet cell. This is a columnar, and the nucleus is here, right? So these nuclei exist at different levels. Some of these, like smaller ones, like they might come up through here. You don't really see that, so just keep that in mind. But like this one, that's a good example. If you can see, it's just all over the place. But you should be able to see that they all kind of attach to the same like basement membrane. Okay. So scroll around in those. Take a look at the lamina propria, right? This dense irregular connective tissue, like this. Finding some glands, right? Like what do they look like? And what lines them, right? So take a look at that and figure out that these are cuboidal epitheliums, right? So there's little cubes right there. This is a good example. Right. Yeah, this one too. Okay. And then also look at the repetition, right? So loose connective tissue, and you can see it's super loose all around here. Okay. And then I would also recommend you can compare it to the esophagus if you want. We haven't gotten there yet, but you're more than welcome to get ahead. And you can see the simple epithelium that lines the esophagus. So, right, because this is flat. So squamous epithelium lines the esophagus. Okay. So if you have two pictures next to each other, and the other thing too is like there's cartilage here, right? So this is holding this open. All this purple is cartilage. This is dense connective tissue, which is cartilage. Okay. So like if you have a picture like this, you put a pin here, and you put a pin here, and you say which one's which. Be able to tell the difference. Okay. This is all collapsed. So when you eat, it would open up, kind of like that, but you're not going to get the side of it open. Okay. Take a look at this, the lungs too. This is kind of closer to alveoli, right? Because we see these airway structures. And if we zoom in all the way, you can see that it's squamous epithelial cells, right? Over here. But if we move towards, say, the bronchioles, that's a vessel. Hang on. This is bronchioles. You can see we see those goblet cells and the pseudo stratified columnar epithelium, right? There's some cilia right there. And you can see that this is all columnar stuff, right? So this is a bronchiole. This is an alveoli. This is an alveoli. That's an alveoli, okay? So you have alveoli, and then you have vessels right next to them, too. Okay? This is artifact. So yeah, look through those different kind of cells, right? Epithelial cells, and be able to identify those. Yeah, just more line pieces. Take a look at all these. This right here, this has what looks like some cartilage. So would we be probably looking at a primary or secondary or tertiary bronchus? Probably primary. You're right. Yeah, there we go. Cool. That's all I got for you guys. So keep it up. Keep up the good work. Do literally anything I can grade you on. Okay. I want to be as supportive as I can through this difficult time for all of us. So I get it. I understand. So, but you have to meet me halfway. Do something. Not that you're not doing anything. A lot of you have done a lot of stuff, but just know that you should be paying attention to that. Cool.